So let's combine some logarithmic expressions. We're going to do 4 problems, so they're all going to be a little different. The key that you need to know is that logs are inverses of exponentials. So essentially when you add, the opposite of adding is subtracting, the opposite of subtracting is adding, but adding and subtracting actually follow the same rules. So this concept's going to apply here. When you are multiplying terms, we add exponents. So in terms of the inverse, we're going to switch our terms and our exponents. When you add terms or exponents, the logs, you're going to multiply the terms that they're given. So these logs, if you think of these as exponents, right, this is told to rewrite the expression as a single logarithm. So in this case, we are adding exponents, which means we're going to have to multiply terms. We're going to get log. Our 8 is going to stay the same, and we're going to get 32 times 2. 32 times 2 is 64. And now this can be simplified. So what is the exponent equal to if your base is 8 and the answer is 64? The exponent's going to be 2. So that's how you simplify the first one. So the rule that this is connected to is, x to the a power times x to the b power equals x to the a plus b. You're adding those exponents together. So your bases are the same. That's why we're able to do it. So you need to have the same base. So same thing for the logs. Those bases are not going to change. Only the exponents are going to be combined. All right, second example. So write as a single logarithm. So again, we have an exponent plus another exponent. That means we're going to be multiplying these terms. So we have the same base. In this case, if there's no number, the base is 10. And then we have 7 times 6. 7 times 6 is 42. 10 to some power is going to give us 42. I have no idea what that is. That's a calculator question. So we're going to leave it like this. If you're going to use a calculator, that's just typing buttons. So you can do that on your own, but you can leave your answer as that one single logarithm. So those are the rules for multiplying and adding exponents. In this case, now we have a different type of problem. And here we have a coefficient or a number in front. So again, we have inverses. Well, if we are multiplying, so remember these are exponents, right? So if we have a 3 times our exponent, we have to go back to our rules. When you have a term raised to a power, we are multiplying exponents, which is pretty much what we're doing. So if we're multiplying logs, which is here, we have to raise the term to a power. So for example, if we have x to the a power, and that's being raised to the b, we can rewrite that as a times b. So again, here we have our exponent, and this extra power is essentially turning into our coefficient. So you have a term with an exponent, then we have another power, so that's where this comes from. So we have 3 times the exponent plus an exponent. This 3 has to become our exponent. We have to raise our term to that power. So we're going to rewrite this as log of 4, and that 4 has to be raised to the third power. And then we're adding log of 9. So again, there's no base written, so the base is 10. So you can write that if you need to. 4 to the third power is 64. Then we have log base 10 of 9. In this situation, we are adding logs. So that's the rule from before. That means we're going to multiply our terms. So we're going to get 64 times 9. That's going to give us 576. So log base 10, 576. And I know 10 raised to some power is going to give me 576. That's a calculator question. So you either type it into the calculator or you leave your answer like this in log form. So we went over multiplying terms where you add the exponents. We went over raising a power to a power. There's one other exponent rule that you should remember, which is subtracting. So when we divide terms, we subtract exponents. So again, looking at logs, when we are going to subtract the logs or the exponents, we're now going to divide our terms. So if we have x to the a power divided by x to the b power, I should probably use different letters here. So let's say x to the m divided by x to the n, we would subtract those, m minus n. So that's what we're doing. So again, we have an exponent, that's your log expression, minus, and now we have a coefficient. There's 8 times the exponent. So order of operations, you have to do the multiplying part before you subtract. That means we have to rewrite this. Log base 2 of 512 minus 8 log base 2 of 2. We're going to take that 8, that's your coefficient, and we're going to make that an exponent. So now it's 2 to the 8th power. Log base 2 of 512 minus log base 2, and 2 to the 8th power is 256. We are subtracting our exponents now. This is where this rule comes in. So since we're subtracting the exponents or the logs, we're going to divide. So we have log base 2, and it's 512 divided by 256. Super convenient. That's 2. So log base 2 of 2. So the other two problems we were able to leave. This can be simplified. So that's just a matter of you looking at it and asking yourself, can I figure out what the exponent is? If 2 is my base, and I have to raise it to some power to get that 2 in the parentheses, the exponent's going to be 1. So this actually simplifies to a nice, pretty whole number. So that ends would be 1. So as you're doing these problems, combine them all, and then at the very end, you might actually be able to evaluate them for some kind of rational number based on exponent rules.